All right, so now we go to fuel systems. All right, you'll get a whole lot more of this in Auto 123. But to give you a little rundown, once upon a time we started with carburetors. Okay, carburetors allowed the air to flow in, and we brought fuel to it, and we dispersed it into the engine, and the car ran. And then the federal government said, not good enough, too much emissions, not to mention inefficient and that kind of stuff. So then we moved to throttle body fuel injection, and that was an electronic fuel injector that bolted to where the carburetor was. So we moved on with life. And now we had metered fuel going in there. But that wasn't good enough either, because we had our runners that went into each cylinder that you saw with our intake manifold, and they were all different lengths. So not every cylinder, got the same amount of fuel. So then we went to multi-port fuel injection, and that's here now. So now each cylinder would get its own spray of fuel and get the same amount, and we got better. As time went on, we now have direct fuel injection, where now those injectors spray the fuel directly into the combustion chamber, not into the intake manifold, and now we make even more power. All right, so to give you an idea, a Cadillac CTS, when it was multi-port injection, made 260 horsepower. And the very next year, when it went to direct injection, it made 303. So you can see the gain. Now, this is a return type system. So we have our inline fuel filter. The fuel would flow into here. It would go past the fuel pressure regulator and back to the tank. Most cars nowadays are returnless. So this regulator that's here is mounted in the gas tank over here, and this line goes away. Naturally, less parts, less weight, less engineering to figure out how to route it, less fittings, all across the board. So our stuff that goes into our fuel system is our fuel tank, our fuel pump, right? It could be electrical or it could be mechanical on an older car. Fuel lines, which are made out of metal or plastic. A fuel filter, which may be serviceable or may not be, because it could be built into this fuel tank unit itself. A fuel strainer, known as a sock, that's your first line of filtering. A fuel pressure regulator that is on this car someplace, either in the tank or on the fuel rail. A carburetor if it was carburetor. A fuel injector if it was fuel injected. Every car has a throttle body. This is a throttle body that contained a fuel injector, but your average car now has a throttle body that has the throttle plate in. You have a fuel rail that houses the injectors. You have a fuel pump relay, which is responsible for turning on the fuel pump from the computer. You have a PCM, a computer that actually turns the fuel pump relay on. And then you have a fuel tank sending unit that allows for your gas gauge to work, right? There's a float that sits on top here. So we started with carburetors, we moved to throttle body, we moved to multi-port injection. That became sequential fuel injection, meaning we fired each injector in the same order as the firing order when the spark plugs are fired. And now we have direct injection. But now we're going to move to the ignition system. Once again, this is reduced in the amount of pieces over time. Once upon a time, we had a distributor like this with points in it, right? Mechanical points that had to be set up for the timing of the spark plug. That went away in favor of electronic ignition, where now we had a little module in here that did the same thing as the points, and we had a pickup coil and our distributor cap, and this particular one was known as HEI, high energy ignition from GM, that had a coil mounted in the cap, and it was run off the camshaft, and it would spin and send the spark out of each individual spark plug wire. Now, as time went on, they said, let's get rid of that. We need less pieces, and we got distributorless ignition. No more distributor. We had a sensor that would pick up the rotation of the engine, go to a module that then would command the coils, and we would send spark to the prospective spark plugs. And they said, let's do away with those, and let's go to coil on plug. So now we have coils mounted directly on top. The computer might be controlling them. They might have a little brain built into them, or they might just be doing what they're told. But now there's no more spark plug wire. So we don't have any kind of ignition leakage or anything like that that used to go bad all the time. On LS engines, we have coil near plugs. So the coil's mounted on top of the spark plug, and we have a little tiny ignition wire that goes into it, right? So this was a distributor. This was distributorless. These are distributorless too because they don't have it, but these are known as coil on plug, and this is coil near plug. All right, so our phases of combustion. We have intake, right? The intake valve opens up. Now this piston is sealed to the surface here, so it's actually like a hypodermic needle, right? It's like a syringe. It pulls downward as it moves through its motion and draws the air inside. That's where your engine vacuum comes from. Afterwards, the intake valve closes, the piston comes up, it squeezes that mixture, it can't get out. Now it's under pressure, that's compression, and then the spark plug ignites, which expands the gases, which drives the piston downward. When that goes downward, our crankshaft turns, right? That's our power stage. And then afterwards, it's all spent. We burnt everything up inside. The exhaust valve opens up, the piston goes up and ejects everything out through the side. That is our exhaust. So we have intake, compression, power, exhaust. In the next part, I'm going to give you a chance to see that happening.